Hello and welcome to this tutorial. Now let's solve this challenging physics question. Now let's read the question together. A soldier at position P fires a mortar shell with speed root AG at an angle theta above the horizontal, where A is a constant, okay? P is at a vertical height B above a horizontal plane. Okay, the shell strikes the plane at the point Q, and O is the point at the level of the plane vertically below P. Now, to be able to solve this question, now the first thing we need to do is to draw a diagram, to analyze the problem. Now, we are asked to obtain, that's our first task, is to obtain this equation and to show that the maximum value of x, which is the horizontal distance, as theta varies, as the angle varies, so is this, and that this is achieved when tan theta is equals to square root of a over 2b plus a. All right, so like I said, our first inclination is to draw a diagram to analyze the problem. So I'm going to read the question one more time. So we have a soldier at position P fires a mortar. Now, when we say a soldier at position P, that means a soldier is not on the downturn level, is not on the ground. Okay, so the soldier, let's say the soldier is standing on a platform and we have that the position is P. So let's say we have, this is solution, we have that the position of the soldier is P, is at a vertical height B above a horizontal plane. That is the height of the soldier, okay, above the horizontal plane is B. Okay, this is the horizontal plane. Let's not forget that the soldier fires a mortar shell at a speed of U equals to AG. So this goes this way, then it lands on the horizontal plane at Q, because we have here that above a horizontal plane, the shell strikes the plane at the point Q. So let's say this is the point Q, and O is the point at the level of the plane vertically below P. So that will be, this is O. Okay, so then we have that letting OQ equals X. So the distance from O to Q is X. OQ is X. OQ is X. Okay. Now the inclination with the horizontal above the horizontal plane is theta. So the first thing I'm going to do from here will be that, okay, we need to understand that we're given initial speed. We're given the initial speed, which is U equals to AG. Okay. We're given the initial height, which is B. Okay, the initial height is given to be B. Then we're also given the what? Angle of inclination. We're given the angle of inclination, which is theta. Angle of inclination is theta. What again? We're also given the horizontal distance x. Now, when we look at this question, there are two possible motions. Looking at, there can only be two motions as far as this diagram is concerned. We have the horizontal motion and the vertical motion. Okay, we have the horizontal motion and the vertical motion. This is the y-axis. Okay, this represents our x-axis. So this is the y-axis. So for horizontal motion, we're going to have x, which is the horizontal distance, to be equals to horizontal component of velocity multiplied by time, because we know that velocity measures distance over time. All right, so which means horizontal distance will be U cos theta multiplied by time t. So let's call this equation 1. That's equation 1. Now for vertical motion, like I said, there are two motions in this case. So for vertical motion, we have, this is y, okay? So this is the initial height. So it means that we're going to use y minus b, yes, y minus b, that will be equals to uy multiplied by t, then minus 1/2 of gt squared. So that y will be equals to uy multiplied by t minus 1/2 of gt squared plus b. So this is the equation. This is the second equation, which is the equation for vertical motion. Now from this equation, okay, now let's not forget that uy, okay, uy will be u sine theta. That is the vertical component of velocity. So from this equation, we can say now the next thing to do is to what? Is to find, let's find the time of flight, okay, time of flight. We know that the time with which the particle remain in space, or the time for which the particle has been projected, is what we call time of flight. And at time of flight, the vertical position will be equals to 0. That's why y will be equals to 0. So I can say at t, y will be equals to 0, so that this will be 0 equals to u sine theta multiplied by t. Remember, uy is what? Uy is equals to u sine theta, where u is the what? The velocity of projection. So we have u sine theta times t minus 1/2 of gt squared plus b. Now let me rearrange the equation so that we can have a standard quadratic equation in t. Okay, so I'm going to bring this to the left hand side. So this will be 1/2 of gt squared, okay, 1/2 of gt squared, okay, then minus u sine theta t, then minus b. That will be equals to 0. Okay, so that's it. All right, so now we have a quadratic equation. So we can then use quadratic formula to obtain the what? To obtain t. Okay, the equation for t. All right, so we know from here that applying quadratic formula, we know that t will be equals to negative b plus or minus square root of b squared minus 4ac divided by a. So from here, a, okay, a will be equals to 1/2 of g. So a equals to 1/2 of g, then b is equals to minus u sine theta, okay, minus u sine theta, and then c equals to negative b. So we can then say that t equals to minus negative u sine theta, that will be u sine theta plus or minus the square root of minus u sine theta raised to the power of 2, minus 4 times a, which is 1/2 of g, then times c, which is minus b, okay, divided by 2 multiplied by a, which is 1/2 of g. So 2 we cancel 2, 4 divided by 2, that's 2, minus times minus, that's plus. So we have t equals to u sine theta. Now in this case, t can only take positive value, not negative, okay? So we are going to neglect the minus, so that we can have t equals to u sine theta plus square root of u squared sine squared theta, okay, minus times minus, that will be plus. This is 4 divided by 2, that's 2. Then we have 2gb, okay, all over g. So this is the equation for time of flight. Now, let's not forget that our goal, okay, is to prove or to obtain this equation x squared tan squared theta minus 2ax tan theta plus parenthesis x squared minus 2ab. That's our goal. And the only way we can achieve that is when we make use of equation 1, which is the equation for horizontal distance. So why it is important for us to first calculate the time of flight is because in order for us to achieve our goal, okay, we need to what? Consider vertical motion. All right, so now I'm going to substitute that guy into this equation. So substitute equation, let me call this equation 3. Substitute equation 3 into equation 1. So we have x equals to u cos theta, okay, equation 1, then multiply by t. That will be multiply by u sine theta plus square root of u squared sine squared theta plus 2gb, okay, divided by g. Now, let's recall from the question we are given that the soldier at position P fires a mortar shell with speed root ag. So that means we can now substitute root ag for the what? The velocity of projection. That's the speed. So we can say substitute root ag for u. Okay, then we're going to have x equals to root ag cos theta divided by, I can then write, I'm going to bring this under it. That will be root g squared. We know that the square root of g squared will give us g squared. Then multiply by u sine theta plus the square root of u squared, okay, sine squared theta plus 2gb. Okay, now, because I need to eliminate g in this case, so I'm going to have x to be equals to, this is going to be root ag over g squared multiplied by cos theta, open parenthesis, sine theta, u sine theta plus the square root of u squared sine squared theta plus 2gb, close parenthesis. All right, so this, we cancel this, then we'll be left with x equals to root a cos theta divided by root a cos theta divided by root g. Okay, then we have u sine theta plus square root of u squared sine squared theta plus 2gb. So now let me multiply this equation by root g just to get rid of this guy. Okay, so I'm going to get x root g equals to root a cos, let me open the brackets, so open the parentheses, root a cos theta, multiplying this, that will be u sine theta, okay, that will be u sine theta, that's u sine theta. Then we can now have plus root a multiplied by, that is root a cos theta multiplied by square root of u squared sine squared theta plus 2gb. Okay, then now I can move this to the left hand side, so that on the left hand side will be x root g minus root a cos theta u sine theta equals to root a cos theta square root of u squared sine squared theta plus 2gb. Okay, so now from here, let's square both sides, because of course we want to obtain this equation. Let's square both sides. So squaring both sides, so please, I'm going to write the left hand side. That is, left hand side will be equals to, when we square the left hand side, that will be x root g minus root a, because of space, then cos theta u sine theta raised to the power of 2. So let's get the left hand side. So this will be x squared g minus 2 root ag, yes, times x cos theta sine theta multiplied by u. Okay, then plus square of this, that will be a cos squared theta. Okay, then sine squared theta, then u squared. Okay, so this is the left hand side. Okay, this is the left hand side. Now let's deal with the right hand side. So for the right hand side, so if you square the right hand side, squaring the right hand side, so we're going to get square of this, that will be root a cos theta. Okay, root a cos theta multiplied by root u squared sine squared theta plus 2gb. Then I'll raise that to the power of 2 so that the right hand side can be a cos theta. Okay, the right hand side can be a cos theta, then multiply by u squared sine squared theta plus 2gb, because the square root sign will disappear when we take square of both sides. Then let me distribute this so that we can have a cos theta sine squared theta, then u squared plus a cos theta. That's a cos theta times this, that will be 2a gb cos theta. 2a gb cos theta, that's correct. Okay, now we have this is the right hand side. Okay, now we expanded this to get this. So we have the left hand side, which is x squared g minus 2. Now let's not forget that root ag is what? U. So that will be 2u of x cos theta sine theta. Then we have u again. So that means u times this u, that will be u squared. So this will be u squared. That's u squared. Then plus a cos squared theta sine squared theta u squared. This is the left hand side. So this is now equals to the right hand side, which is a cos theta sine squared theta, then u squared. Okay, which is this again, which is what we have on the left hand side. Then plus 2agb cos theta. So this will cancel this. So we'll be left with, so let me continue from here. So we'll be left with, so after these two cancelled out, we'll be left with gx squared, okay, minus 2u squared of x, then cos theta sine theta. That's what we have on the left hand side. Now that will be equals to 2agb cos theta. So the next thing to do from here, this is continuation. The next thing to do from here will be, let me divide both sides. Divide both sides by g cos squared theta. So if I divide both sides by g cos squared theta, gx squared divided by g cos squared theta, that will reduce to x squared over cos squared theta minus 2u squared x cos theta sine theta divided by g cos squared theta. Okay, this will be, now we know that square of, that is u squared, is the same thing as ag, because u equals to root ag. So this is same thing as when we have 2ag divided by g cos squared theta. Then we have cos theta sine theta. This will be 2agb cos theta divided by g cos squared theta. G cos squared theta. So this will be x squared multiplied by sec squared theta. G will cancel g. Where is our x? Okay, there is x. This. Okay, so cos, we cancel one of the cos here. We will be left with sine theta over cos theta. So this will be minus 2ax tan theta, because sine theta over cos theta. Let's not forget that when this cancel one of these, we'll be left with cos theta under, then this is sin theta. So and we know that tan theta is sin theta over cos theta. Okay, so that this will be, now when this also, when we cancel out from here, okay, so yeah, okay, this will be cos squared theta. This will be cos squared theta. Yeah, this will be cos squared theta. So we have this to be cos squared theta. Yeah, so cos squared theta. So cos squared theta will cancel cos squared theta. G will cancel G. Then on the right hand side, we're going to have 2ab. We're going to have 2ab. Okay, we're going to have 2ab. So I'm going to move this down here, but we know that sec squared theta is the same thing as 1 plus tan squared theta. 1 plus tan squared theta. So this will be x squared into 1 plus tan squared theta minus 2as tan theta minus 2ab equals to 0. So if you distribute x, in this case, we have x squared plus x squared tan squared theta minus 2ax tan theta minus 2ab equals to 0. So I'm going to move this here so that we can have the equation to be x squared tan squared theta minus 2ax tan x, okay, then plus x squared plus x squared minus 2ab equals to 0. So we just obtain the equation, which is this equation. We just obtained the equation, and that is the first question, which is our first task. So this one is when we square it, so we're going to get cos squared theta in that case. All right, so now, so this is the first question. All right, the second question is show that the maximum value of x as theta varies is this guy here. So in this case, what this tells us is that we can use discriminant, and in this case, we're going to have the discriminant to be greater than or equals to 0. Greater than or equals to 0. So this is an equation, a quadratic equation in tan theta. Okay, so we want to obtain the value of x, the maximum value of x. So we now consider the equation to be an equation in tan theta because the discriminant is non-negative. So to obtain the maximum value of x, we make use of discriminant to be greater than or equals to 0. And what's the discriminant? So here, we have an equation in tan theta. So we have an equation in tan theta. So this is A. So A equals to x squared. Then B equals to minus 2as. YC will be equals to x squared minus 2ab. Okay, minus 2ab. So we are using b squared minus 4ac greater than or equals to 0. So this will be b squared minus 2as raised to the power of 2, then 4 multiplied by x squared, okay, multiplied by x squared minus 2ab greater than or equals to 0. Okay, that makes sense. So this will be 4a squared x squared. Okay, when we distribute this will be 4x to the 4th power. Then this will be plus 8abx squared greater than or equals to 0. Okay, so now let's divide through by 8. If you divide this by 4 rather, if you divide this by 4, this will reduce to a squared x squared minus x to the 4th plus this will be 2abx squared greater than or equals to 0. Greater than or equals to 0. Okay, now again let's factor out x squared. we know that x squared open bracket a squared minus x squared plus 2ab greater than or equals to 0. So that means that x squared is greater than or equals to 0. That's we have a quadratic, we have product zero product rule. Okay, in this case, so we set this greater than or equals to 0. Then in this case, we have a squared minus x squared plus 2ab to be greater than or equals to 0. We want to solve for x, so we have x squared. If I move it to the other side, that will be less than or equals to a squared plus 2ab. Yes, a squared plus 2ab. So if you take the square root of both sides, square root of x squared, okay, less than or equals to a squared plus 2ab. So we have x to be, because we want to find the maximum value. So the maximum value of x will be when we have x to be less than or equals to square root of a squared plus 2ab, which is same thing as x which is less than or equals to square root of a into a plus 2b. So this is the maximum value of x. That's the maximum value of x. So the last one is for us to what? Now, and that this is achieved when tan theta, okay? This is achieved when tan theta equals to this. So we now go back to this equation. We go back to this equation. So if we go back to this equation, then we substitute this for x. Yeah, we substitute for x. Okay, so the third question. Oh, yes. So we want to achieve this. Okay, to achieve that, tan theta equals to root a over a plus 2b. So now let's recall. We have that x squared tan squared theta minus 2ax tan theta plus x squared minus 2ab is equals to 0. Now we have x to be this, so we have root a into a plus b, okay, a plus b, that's x, then raised to the power of 2 tan squared theta minus 2a, then we have root a into a plus b, okay, tan theta, this one, then plus, we have again root a into a plus 2b. It should be 2b. This is 2b. Okay, 2b raised to the power of 2 minus 2ab equals to 0. So this will disappear. So we're going to have a squared tan squared theta. I want to expand this. Okay, then 2ab times, so that will be plus, that will be 2ab tan squared theta. Then in this case, minus 2a root a into a plus 2b tan theta. Okay, this will disappear. So this will be plus, this will be a squared plus 2ab. Okay, then minus 2ab equals to 0. 2ab minus 2ab, that will be 0. Okay, so now so now the next thing to do is let's divide both sides by a. Okay, a plus a, that will be 2a. Okay, 2a squared plus a squared, that will be 2a squared. That will be 2a squared. That's 2a squared. So let's divide both sides by a. So 2a squared divided by a, that will be 2. Okay, this is a squared plus, okay, this will be a tan squared theta plus 2b tan squared theta plus minus 2 roots a into a plus 2b, okay, 2b tan theta, then plus a equals to 0. Okay, so now what we have now is more like a yes. So what we have here is a perfect square. Yes, this is a perfect square. This is a perfect, this is a perfect square. That is, it will be root a tan theta, root a tan theta, okay, minus root a raised to the power of 2 equals to 0. Equals to 0. Okay, these two are together. Okay, yeah. So that will be, this will be tan square theta. Okay, this will be a plus 2b. Yes, because we have a tan square theta plus 2b tan square theta. So this will be root a plus 2b, root a plus 2b tan theta, then minus root a. This is a perfect square. These two, if you factor out tan square theta, we're going to have a plus 2b, okay, in a bracket, multiplied by tan square theta. So in this case, if you square both sides, so if you take the square root of both sides, so this will reduce to root a plus 2b tan theta minus root a equals to 0. I'll move this one outside so that tan theta, that is root a plus 2b tan theta, will be equals to root a. So if you divide both sides by root a plus 2b, root a plus 2b, we're going to have tan theta to be equals to square root of a divided by a plus 2b. And we just, after we show that x is maximum as theta varies, okay, and this can be achieved when tan theta is equals to radical a divided by a plus 2b. And we've come to the end of this tutorial. The noblest pleasure is the joy of understanding. Bye-bye.